Okay. Good morning to everyone. Today we'll discuss about the cross product of two vectors. So here I have represented two vectors in general, that is A bar and B bar. Uh, uh, Bar is used to represent as a vector. So if you skip this one, then it becomes a scalar or the magnitude of a vector. So vector is represented with the bar on that letter. Okay, so A bar is taken as a ax bar plus ay bar plus az bar, where ax bar, ay bar, az bar, small ax bar, ay bar, az bar are the unit vectors along the x direction, y direction, z direction. Nothing but they are the directions of three coordinate axes, x, y, and z. So any vector generally can be represented in terms of the components along that coordinate axis into unit vector corresponding to them. So this is the representation of a vector. Similarly, B bar is taken as a Bx Ax bar, By Ay bar, and Bz Az bar. Here Ax bar and Ay bar and Az bar are the directions of different coordinate axes. So while representing this will be common. Okay, these directions are common, but whereas the only the magnitudes, that means components of different vectors along x direction, y direction, z direction will change. That's all. That means here only the component of B bar along the x direction will be changing and along y direction or z direction. Even if you take different vectors in electromagnetic fields, electric field intensity, magnetic flux density, they have the components, different components along the x direction, y direction, z direction. Representation of that is like this. So we have to represent x component and the direction, y component, the direction, and z component and the direction. So these are the components of that vector along the z x-axis, y-axis, z-axis, or the projection. If you project that vector along that direction, then you get, okay, or the component of that A bar on Ax bar you can take. That concept of component or the other vector, we take it as a dot product. Next class we'll discuss that one. Today we concentrate more on the cross product. Okay, cross product between two vectors, that is A cross B bar. How to calculate A cross B bar, so that we'll see. From definition, A cross B is taken as A B sin theta, AB sin theta, and AB sin theta, and this is the magnitude, and the direction of this one is given by AN bar, where AN bar is the unit vector normal to both A bar and B bar, or plane containing A bar and B bar. See, so this is the magnitude. This cross product is also called as a vector product. The resultant is a vector. You can see that this is a vector and having magnitude AB sin theta. If you consider two vectors, A bar, same vectors A bar and B bar, with the angle between them is theta, then the cross product is taken as AB sin theta and unit vector perpendicular to both A bar and B bar. Here we are considering the direction and it is calculated using right hand thumb rule. Turn your fingers from A to B, thumb gives the direction of A cross B bar. So the direction of A cross B bar in this case is given by the dot enclosed. You can see that, okay, the direction of this A cross and B bar is given by dot enclosed. That means towards us. Now you take same thing, okay, same two vectors A bar and B bar. Here, if you take B bar cross A bar, okay, take B bar cross A bar. If you take B bar cross A bar, then turn your fingers. Here we are discussing only the about the direction. So magnitude is same. A cross B bar or B bar cross A bar, the magnitude is AB sin theta. The angle between A and B or B and E, B and A is same theta. So theta is same, A magnitude, B magnitude is same. Only the difference once you take B cross A bar is that in this one, that is the direction. The direction of B cross A bar is obtained by using a right hand thumb rule or right hand rule. If you turn your fingers from B to A, B to A, then you get a vector into the paper or it is away from us. That direction is represented with cross enclosed. Already told there are two directions which are used to represent into the paper, out of the paper, or towards us, away from us. This notation is used to represent a vector towards us, direction towards us, when it is moving towards us. When it is moving away, any vector generally when it is moving away from us or into the paper, so the direction is given by cross enclosed, and it is nothing but it is taken as a when arrow coming towards you, you can see only the tip of that arrow, but whereas when arrow is going away from you, you can see like this. Okay, so that is the representations of different directions into the paper, and this is into the paper and this is away, that is towards us. Away means from that towards us. Okay, not this is not into the paper, please remember, this is out of the paper or towards us. This is into the paper, that is away from us. So these are the two different directions used to represent. So A cross B direction is dot enclosed and B cross A direction is cross enclosed. How do you get this one? Again, I'm repeating, just using right hand thumb rule. Okay, if you turn your fingers from first vector to second vector, because the vectors are represented in a plane, so you can take it as a vector. Okay, if you turn your fingers from the first vector, in the first case that is A cross B bar, you will have you have to turn your fingers from A to B. Just turn your fingers from A to B, thumb is towards us, so that is dot enclosed. And now you take your right hand and turn your fingers from B to A. Thumb gives the direction B to A. So then that is into the paper or from away from us. So that is taken as a cross enclosed. So the directions of A cross B is different from B cross A. That means A bar cross B bar is different from B bar cross A bar. So that is just quite opposite. Once you see the magnitudes of A cross B as AB sine theta and B cross A is also AB sine theta. Only the difference is that the directions. It is a unit vector, so it has unit magnitude. So it only represents the direction. So the direction is this is in towards us, away from paper. It is into the paper or away from us. Okay, then once you take two vectors, how to calculate this A cross B bar, that we'll see. So before discussing about this one, we take simply okay, what is A cross B bar? Okay, AX bar cross okay, AX bar we consider, okay, and we calculate. That is the dot product between two simple unit vectors, that is x-axis direction versus again x-axis. Okay, so the A cross B, using the above formula, if you substitute, okay, AX bar cross AX bar, this is equal to AB, magnitude of AX is 1, magnitude of again ax is 1, and sine of the angle between same vectors, same vectors, these are same. Or even if you consider a parallel vectors, if you consider a two parallel vectors, a bar and b bar, a bar and b bar, if they are parallel, the angle between them is theta is equal to 0. If you say that two vectors are said to be parallel when the angle between them is 0, 0. So once you substitute that theta is equal to 0 in this one, you get 0 magnitude multiplied by again vector gives null vector or 0. So A cross B is equal to 0 once they are parallel to each other. Once they are perpendicular, if you take A bar cross B bar, once they are perpendicular, you will get, okay, you can see that A cross B bar is given by A, B sine theta. This theta is equal 90 degrees. So that sine 90 becomes 1. So this is equal to sine theta is equal to 1. So AB, AN bar you will get. AB, AN bar. So that it is maximum. Maximum, you will get maximum value of this one once theta is equal to 90 degrees. Okay, you will get the cross product, the magnitude is maximum once the angle between them A and B is 90 degrees. 90 degrees. Okay. If it is in between 0 and 90, less than 90 degrees, then this value is always less than 1. So you will get the magnitude less than that. Okay. So here, once you consider the same vectors in parallel, so the angle between them is 0. So sine 0 is equal to 0. Even if you multiply with the resultant, that is unit vector, you get 0, because anything multiplied with 0 you get 0. Even it is a vector, if you multiply with 0 you will get 0. Okay, so ax bar cross ax bar is equal to 0. Then similarly, if you take ax bar cross ay bar, because once you take the cross product between this a cross b bar, you have to take ax bar cross ax bar and ax bar cross ay bar, ax bar cross az bar you have to take. Now we see the second one, that is ax bar cross ay bar, ay bar. So this is equal to same by substituting these in this one ax place we are in a place you are assuming ax bar, in b place you are assuming ay bar, and this is equal to ab. Ab means magnitudes, again they are equal to 1, because we have assumed in electromagnetic fields such that these small a represents the unit vector. Small a is used to represent the unit vector. Okay, so here the magnitude is unity. Then sine, once you see the sine of the angle between ax bar and ay bar, we know, you might have experienced, okay, a number of times you might have drawn a graph. Okay, we know that, okay, we know that x-axis is perpendicular to y-axis. The angle between them is 90 degrees. We know that, okay, 90 degrees, because they are perpendicular to each other. So the direction of this one is taken as ax bar, and the direction of y will be taken as ay bar, and these are the unit vectors. Okay, unit vectors, magnitude is 1 and direction is along this one. So x direction is along this one. So x bar and ay bar, so they are the directions. Okay, now ab, that is the magnitudes of ax bar, ay bar is equal to 1, and sine of the angle between ax bar and ay bar is equal to 90 degrees. Sine 90 degrees is equal to 1. And then now you think about the direction, that is an bar. An bar, an bar is obtained using right hand thumb rule or right hand rule also. If you turn your three fingers perpendicularly, that is middle finger, forefinger and thumb, then okay, this x-axis and y-axis, and if you take this gives the z-axis. Okay, but here The problem is that okay, here we are calculating. Here we are calculating this one, that is the AX bar cross AY bar. AX bar, turn your fingers from X direction to Y direction. That is right hand thumb rule. I am assuming right hand thumb rule. Turn your fingers from X to Y. Thumb gives the direction of the resultant AX bar cross AY bar. Okay, so that is along towards us. Okay, that is along this direction towards us. Okay, towards us. This direction is taken as a towards us. Okay, that is Z direction. Already I have introduced Cartesian coordinate system. Their X direction, Y direction, and Z direction, they are perpendicular to each other, and they are represented, okay, using right hand system, because that is the positive coordinate system, and that is also called as a orthogonal coordinate system. Orthogonal coordinate system means each coordinate axis is perpendicular to the other. Okay, for example, each they are perpendicular to each other. X is perpendicular to Y, Y is perpendicular to Z. So here, if you consider the resultant of AX bar cross AY bar, that gives the AZ bar, that is AN bar is nothing but here AZ bar, AZ bar. How do you get? Using right hand rule. Okay, thumb rule, right hand rule. Turn your fingers from X to Y, so thumb gives the Z direction. That's why here I am taking Z direction. So finally cross ax bar cross ay bar, ax bar cross ay bar is equal to az bar. That is very important. You get the other, and you have to see that plus az bar. Okay, plus az bar. Okay, then if you take the other, that means here a y bar cross ax bar, if you take a y bar cross ax bar, you will get minus az bar, because here already I told in this example, I have already told that a cross b direction is dot enclosed, that is towards us, but whereas b cross a bar is cross enclosed, that is away from us. So just only the direction is different. So here itself I am writing a y bar cross cross ax bar gives minus az bar. Okay, ay bar cross ax bar gives minus az bar. This is minus az bar. Please remember, okay, or I will give you the short way of remembering this cross product. Okay, so here I will tell you all cross products between different vectors. I will tell you. Okay, see, the cross product between ax bar and ax bar is equal to 0. See this. Okay, the cross product between ay bar and ay bar is 0. The cross product between az bar and az bar is equal to 0. Then the cross product between ax bar and ay bar is equal to az. The cross product between ax bar and az bar. How do you calculate this one, ax bar and ay bar? See, the cross product between az bar and ax bar, you will get it as a ay bar, but ax bar cross az bar, you will get it as a minus ay bar. I will explain. Okay, or a simple way of representing this I will tell you. Okay, see, okay, see here. Okay, how to calculate or how to remember the cross product between three different vectors, that is ax bar and ay bar and az bar. So how do you represent or remember the cross product between these three? Okay, see, you represent the directions in clockwise. That means ax, ay, az. See, ax, ay, az bar. So these are the three unit vectors. Now I will tell you how to remember the cross product between these vectors. See, ax bar cross ay bar is equal to az bar. Just if you go in a clockwise direction, okay, you can easily say ax bar cross ay bar is equal to az bar. Ay bar cross az bar is equal to x bar. Az bar cross Ax bar is equal to Ay bar. If you go in anti-clockwise direction, you will get it as a negative. That means Ax bar cross Az bar. Just now I have seen, okay, Ax bar cross Az bar. That is equal to minus Ay bar. If you go in anti-clockwise, you will get negative. If you go in the clockwise direction, clock, if you take a hand clock or wall clock, if you take clock will rotate in this direction. So that is taken as this one, okay. Anti-clockwise direction means opposite, okay. So you represent the ordinary x, y, z in a clockwise direction, and then if you take the cross product in this direction, that is Ax bar cross Ay bar, simply the other Ay bar cross Az bar, simply the X bar, Az bar cross X bar is simply Ay bar. If you go in anti-clockwise direction, so that is Ax bar cross Az bar is equal to minus Ay bar, Az bar cross Ay bar is equal to minus Ax bar, Ay bar cross Ax bar is equal to minus Az bar. This is the way to represent the cross product between these two vectors. Now we are taking A cross B like this, okay, and it is Ax. This is, if you take cross product between these two is 0, and if you take cross product between these two, you get Ax bar cross Ay bar, Ax bar cross Ay bar as Az bar, so that you will get Ax By, and Ax bar cross Az bar is equal to minus you get, that is Ay bar, so that is equal minus Ax and Bz, and like that you take Bay cross Ax bar, you will get minus, that is minus Bx and Ay, and similarly this one you will have this product is 0. And one more, okay, this is okay, we don't multiply this one in this fashion. We remember, okay, see, we calculate the dot product between two vectors, that is A cross B, in different, that is we take it as a matrix form, and we calculate the determinant of the matrix form that gives the A cross B bar, okay. So we take here, okay, the cross product between two vectors will be taken like this, okay. See, A cross B bar, A bar cross B bar is given by, okay, the determinant of this matrix, determinant of this 3 by 3 matrix, that is represented as okay, Ax bar, okay, and Ay bar and Az bar. Even if you calculate A cross B bar by multiplying, that is cross product between this first term, second term, third term, second term, first term, and so on, you will get the same thing, okay. You can do that, okay, but instead of that one, you just directly get from the determinant of this matrix, okay. So that is here we take the component of x, that is Ax, Ay and Az, okay. Ax, Ay, Az we take here, and here Bx, By, Bz we take, Bx, By, Bz, okay. So that is the cross product. The determinant of this one gives the cross product of A bar and B bar, okay. See, so the determinant, how do you calculate, okay, this you might have తెలిసే ఉంటుంది, you might have known, okay, the cross product. So simply Ax bar into this one, okay, the multiplying this and subtracting from these two, okay. So that is Ax bar into, or simply Ax bar into determinant of again this Ay and Az, Ay and Az, and By and Bz, okay. So By and Bz, okay. Or simply you can take, instead of this one directly I am writing, okay, instead of this one I am writing directly the resultant of that one. So here we take simply Ax bar into, or Ax bar you can post multiply, you can pre-multiply or post multiply. If it is a constant, you can take 3Ax bar or Ax bar into 3, anything is correct, okay. Generally we multiply the magnitude starting, we write magnitude starting and then vector the next, okay. So you can write the you can write this magnitude and you can pre-multiply this vector, or later we can adjust. Okay, see, ax bar into ay bar, ay into bz. So ay into bz, you get it as ay into bz, okay, minus ay into bz minus actually determinant of this matrix. Okay, determinant of this matrix, ax bar into ay bz minus az by. Okay, that is the determinant. Actually is taken as az into by. Okay, so this is the ax bar component, that is by. Similarly, you can write the other minus ay bar into, okay, you can take minus ay bar into this one. You can consider uh, uh, you can consider that one. Okay, so here next one, that is minus, because quotient we take for this ay bar, we take minus ay bar. Okay, minus ay bar into, okay, simply ay bar means you, if you skip this column, okay, this column, you get ax bar and bj, ax and bz. So this is ax into bz minus, you can just skip this. Okay, minus az minus, okay, az into bx, az into bx. Okay, here remember I have taken minus starting. Okay, minus ay bar into ax is multiplied by bz and bx is multiplied by az. Some people take positive and they take this one, and okay, that is different. Here I am taking minus ay bar into ax bz minus bx az, and last term is simply az bar into determinant of matrix. Simply you might have done, you might have, okay, determinant of this one. So that is equal to ax into, that is ax into by minus ax into by minus bx into, or ay into bx. So this is the final answer for calculation of cross product. This is not so easy when compared to the dot product. Okay, so this is about cross product between two vectors. Simply ax bar into determinant of this one minus ay bar into determinant of ax, az, bx, bz, and az bar into determinant of this 2 by 2 matrix, that is az bar into ax by minus bx ay. So this is the answer for a cross product between two vectors. Okay, now, okay, we'll see one example, and then okay, with that we close this today's class. Okay, we take one example. Okay, okay, here I am taking a simple example to calculate the dot product between two vectors. I am taking simply 3ax bar plus ay bar, 1 into ay bar, or simply ay bar, and minus 2az bar. 2az. Simple example I am taking. Okay, then some other vector b bar is taken as, I am taking complete vector. Okay, this is equal to, okay, 2ax bar minus 4ay bar and plus az bar I am taking. 1 into az bar, or simply az bar I am taking. So then how to calculate a cross b bar? So a cross b bar is calculated using the determinant of 3 by 3 matrix. So this is equal to ax bar, ay bar, determinant of 3 by 3 matrix, ay bar and az bar. This is like ijk. If you have already taken these vectors as ijk, you can take it as ijk. Okay, you can take it as ijk. Okay, see, determinant of this 3 by 3 matrix. Here a components I am representing 3, A component, y component I am representing, that ay bar quotient, that is 1, and az quotient is taken as -2. Similarly here 2 minus 4 and then 1. So this A cross B bar is nothing but a determinant of this 3 by 3 matrix. Okay, so here I am taking, okay, this Ax bar into determinant of this 2 by 2 matrix, that is 1 into 1, simply 1, minus 4 into -2, 8, minus minus plus, okay, 8. So 1, this is 1 minus 8, okay, minus ay bar into minus ay bar into, okay, ay bar, this minus ay bar into, skip this column, and 3 into 1, so that is 3, minus 3 minus 2 into -2, -4 you will get. So that overall you will get it as a +4, +4. Then next, then okay, az bar into plus az bar into plus az bar into, okay, the matrix, that is determinant of this 2 by 2 matrix, that is 3 into 4, -12, -12, minus 2 into 1, 2, -2. So this is equal to, here 8 minus 8 plus 1, so you get -7 into ax bar, okay, minus 3 plus 4, 7 ay bar, and here minus 14 az bar. Okay, so this is the way to calculate the cross product between two vectors. You can see, okay, so this is the, okay, the cross product between two vectors. If you have any doubt, please ask me, okay, or I will give you the another example. Okay, so this is the way to calculate the cross product between two vectors, okay, is calculated using the determinant of 3 by 3 matrix, where ax bar, ay bar, az bar are the components of first row, and then simply the quotients of ax bar, ay bar, az bar in a vector A will be taken as it is, 3, 1, -2, here 2, -4 and 1. And then here, while calculating the determinant, here ax bar into determinant of this one. Determinant means here AD minus BC. Okay, even for a 2 by 2 matrix, you might have taken determinant of, okay, A, B, C, D. While calculating the inverse of matrix, you might have calculated the determinant. So determinant of this 2 by 2 matrix is given by AD minus BC. So AD minus BC. So this is given by AD minus BC, determinant of that one. So here AX bar into determinant of this matrix is nothing but 3 into -4. Sorry, you have to skip that column. Okay, determinant of this matrix. Okay, AX bar into you have to skip this column. While you are calculating the AY quotient in this resultant vector, you have to skip this one. While you are calculating about AZ bar, you have to skip this one, and remaining you have to take. So AX into X bar into determinant of this one is 1 into 1 minus 1 into 1 minus -4 into -2. -4 into -2, you get it as a 8. So minus of that one is, okay, that is given by -8 we have taken. Okay, so that way we are calculating so the cross product between two vectors. Okay, so while you are taking AZ bar, simply the determinant of this one is taken, that is simply AD minus BC. Okay, AZ bar into 3 into -4 and 3 into -4, that is -12 -2, 2 into 1 -2. So that the way you are calculating while taking AZ bar. But while taking AY bar, you take it as a minus AY bar, and take the determinant of 3, 2 and -2 and 1. You have to skip while you are taking this AY bar, you have to skip this one. So 3, 1 -2, 3, 2 -2, 1. 3, 2 -2, 1. Determinant of this one is 3 into 1 minus of, okay, minus of minus, that is 4 you will get. Okay, 3 plus 4 you get. Okay, so that is the answer, minus AY bar. If you take plus AY bar, then the starting elements you have to take this one. That is confusing, so please take this one. Okay, so while you are calculating the determinant, you take AY bar minus AY bar into, skip this one and take determinant of these two, that is 3 into 1 plus minus 2 into -2, that is 4, plus 4 you get. Still, if you have any doubt regarding this one, and you can